If we're solving an equation such as number 1, first thing I need to do is do my distribution. Then I'm going to need to combine like terms. Then I'm going to need to move the variables to one side, the constant to the other. Exactly the same as before, right? Nothing is changing, only that the problem looks a little bit more annoying to do. What we are going to add is representing our answer using set notation. So once in a while, they will ask you for a specific notation. If they do, make sure you write your answer as such. But we'll worry about that after. So I'm going to start doing my distribution. I'm taking 3, multiplying it to b. All right, that's easy, 3b. I'm taking 3, multiplying it to 2. Another one that's easy, plus 6. Here, I'm taking this color code, negative 2 to b, negative 2b, negative 2 to 2/3. Again, now is where I would use my calculator. Let me go. Negative 2, and 2, negative 2. So times alpha, y equals my nails. Enter. And then you can input your fraction. So we get a negative 4/3. So that was a negative 4/3 equals. I'm going to distribute that 3/5 times 2/5, a 2. And last one, we're multiplying these two fractions together. So technically, again, we can multiply 3 times that negative 20, the 5 times that 9, and we're going to get some fraction. The calculator will always represent your answer in its most simplest form. So I do suggest you put it in your calculator. 3/5 alpha y equals 3/5 multiplied by a negative alpha y equals 20/9. So it's going to give me my answer in its most simplest form. All right, so we get negative 4/3. All right, now that the distribution is done, we're going to go ahead and start combining our like terms. We have these b's that we can combine on this side, and we have these numbers that we can combine. So 3b minus 2b, easy, 1b. 6 minus 4/3, again, sticking with my calculator. We got 6 minus, not negative anymore, 6 minus alpha y equals 4/3. Enter. 14/3. And it is a positive, right? So plus 14/3 equals. Let's drop this piece down. At this point, we're going to move the b's together, the constants together. You decide which way to move it. I'm just going to always move it to the front. Very rare I move it to the opposite side. So let's move that 6/25b from one side to the other. I'll show all my work. So here, if I'm putting this into my calculator, I'm going to press 1 and I'm subtracting this fraction. All right, so we got 1 and I am subtracting a fraction, so minus alpha y equals, we got the 6/25, enter, we get a 19/25. 19/25, we got the b. Bring down that 14/3, bring down the equal sign, bring down the negative 4/3. All right, so got my b's to one side, got to get that constants to the other. So I'm going to minus 14/3 on both sides. Cancels. We got 19/25. B is equal to, again, I'm putting this into my calculator. All right, so this combines to a negative 6. So we're up to the point that we want b completely by itself. Two ways you can do this. You can multiply both sides by the reciprocal, right? That's a true fact. Or you can divide by that fraction. Because if it was a 3b, I would just divide by both sides by 3. You have a calculator, so you can use and do anything you want. So I'm going to say I'm going to divide both sides by that fraction. Right? And then we get b equals a main fraction, and then we have a little fraction here. So our numerator is a -6, and our denominator for this particular problem contains another fraction. So this is how you put it into your calculator. I'm going to open up a main fraction. So that's alpha y equals, enter. My numerator is -6. So I'm going to input -6 in there. Our denominator has another fraction. So I'm going to do alpha y equals on the denominator, and I'm going to input 19 over 25. Enter, the calculator spits out -150 over 19. That is our answer. -150 over 19. If you multiply by the reciprocal, you're gonna get the same exact answer. It's not changing. It's the same equation. You're gonna have that one solution. So this is my final answer, right? Final answer. It was a lot of work to get there because we had a whole bunch of fractions and stuff like that. But we don't want this as our final answer. We want to represent this answer using set notation, it says. So I need to do one more thing. Set notation. I love set notation when I'm solving. When you are solving and writing your answer using set notation, all you need to do is open up a curly brace, close up that curly brace, and whatever you got for your variable, you put that number in here. So I got a -150 over 19, and that's what I input inside curly brace. You do not include the variable. You do not say b equals this. No, that's wrong notation. Just the curly brace itself. So pay attention to if the problem wants it to be written in a specific form. If it does, you must write it in that form. If it doesn't, then you get to choose, right? Do you want to write it in set notation? Do you just want to stop at b equals? That's up to you. It doesn't matter. You won't lose any points. All right, let's do it again. Let's see what happens here. So here we have another equation. We're solving for n. We're representing our answer using this new notation. So I'm going to do my distribution and all that stuff, right? We get 2n minus 12n. I'm distributing, putting in my calculator if I need to. Distribute. We get a positive 15 over 2 equals, keep distributing. We get a negative 7n. Distribute. We get a positive 21. Again, you're putting this in your calculator. If you're good with your fractions, you are saving a little bit of time. We're distributing. Negative 3n. And finally, a -2. All right. Beautiful. There we go, my distribution. I am going to combine like terms just like we did before. So we got that 2n minus 12n on -10n plus 15 over 2 is equal to, let's combine over here, -7n combined with -3n is going to be a -10n. If I combine positive 21 and -2, I get a positive 19. Awesome. All right, I'm going to go ahead and solve. So whenever we're solving, we're moving the variables together. The variables together. What happens when I do this in this case? When I move these variables together, it cancels out, right? We end up with 0, 0n, which is just 0. So I'm just going to drop this down. 15 over 2 equals to 19. There is no more variable. The variable canceled out. Very special cases. This happens. Is it possible that this number, 15 over 2, what is that number anyway? What's 15 over 2? What's 15 divided by 2? 15 divided by 2 is 7.5. Is the number 7.5 equal to 19? Impossible, right? We know our numbers. This is not true. Not a true statement. If it is not a true statement, it is known as inconsistent. If we end up with a not true statement, inconsistent, it means there is no solution. So this is what you would write in this special case. It does not always happen. Normally, we like to solve and get an actual solution, right? In this case, we have no solution. So the problem is asking us to write our solution using set notation, but we don't have a solution. So look at how awesome this is. Set notation. I'm going to start off exactly like I did with the other one. I open up my curly brace. I close it up. But do I have an answer to put in here? No, so I literally leave it like this. This is known as the empty set. It's empty, there is no solution. There is another way to represent it. I'm just gonna use this notation.